All right, hello class. Welcome to this lesson on 8.1. I hope everybody's doing okay and everyone's safe. So we're going to talk about 8.1, which is hypothesis testing. So we're going to split this lesson into two parts. So this will be part one today. I'll be focusing mostly on the vocab part of things, and then we're going to be talking about just how to state hypotheses. So that'll be the main part of this lesson. All right, so we're going to talk about what is the decision-making process for stating and testing statistical hypotheses. So we're going to ultimately, with these two parts, be able to answer that essential question. What is that hypothesis testing process, basically? So the learning goals for today are to be able to state the null and alternative hypotheses, identify type 1 and type 2 errors, choose between a one and a two-tailed test, understand the steps in the hypothesis testing process. So it turns out that we're only going to talk about these first two goals, right? And then the other two learning goals we'll talk in part two. All right, so for the vocab, again, there's very vocab heavy because we're introducing a new unit. And so there are a lot of vocab terms that you need to know. So hypothesis test, statistical hypothesis, null hypothesis, alternative, type 1 error, type 2, level of significance, test statistics, p-value, left-tailed, right-tailed test, two-tailed test. So these are the vocab terms that we'll be introducing in this lesson. All right, so let's go ahead and get started. Let's talk about the idea of inferential statistics. So most of what we did in the first half of the course was what we call descriptive statistics. All right, there are two branches of statistics. There's the descriptive branch and then the inferential branch. The descriptive branch involves describing, okay? So describing a set of data. So for example, finding the dot plot, finding the shape, the graph, that kind of stuff. Finding the mean, the standard deviation, all that stuff, histograms, all that stuff describe a set of data, right? Now we're going to talk about the inferential statistics, which is to infer. Infer means to draw a conclusion. So we want to draw a conclusion about a population parameter based on data that we collected. And this is, for example, an example of this is the hypothesis testing process that we'll be introducing. So this unit will introduce hypothesis testing, which is going into inferential statistics. So again, inferential statistics, the point of it is that we want to estimate or draw a conclusion about the population based on taking a small portion of that population. So let's go ahead and introduce an example. Let's say that we're interested in the US population, the United States, and we're interested in, now that I think of it, I could have used probably a virus example, but, just kind of keeping things, not current. Let's talk about BMI. So let's talk about the average BMI of the entire US population. Let's say you wanted to know what that is, okay? Well, in order to know what that is, what we need to do is we need to take a small portion of the US because it's not possible to sample every single American in the US, right? It's just crazy. There's 600, 700 million people, right? At least in the US. So surveying every single person, not really feasible, right? So what we do is we take a portion of that population. Let's say we wanted to find the average BMI from 100 Americans in each state. And then that's probably more manageable as long as we had a big team to do it, right? And that will constitute our sample. So let's say, for example, that we knew what the population was for the population average was for BMI. Let's say it was 26.6, okay? Now, I don't know if you're familiar with the BMI scale, but 26.6 is overweight considered. It's that 25 mark. If you're above that 25 mark, I guess they consider you overweight and so on. If you're below 25, then I guess you're considered normal up till a certain point. I don't remember what that cutoff is. But let's say we took the sample from 100 Americans in each state. So that's 50 states, so 50 times 100. And we found the averages of their BMI. We got 24.7. And that's considered on the upper end of normal. So there's a discrepancy between our sample and the population, right? the sample characteristic, or the sample mean that we took here, the sample mean, this is called a statistic. So a statistic is a sample characteristic. A population characteristic is called a parameter. So there's a discrepancy between the statistic and the parameter. This is due to sampling error, okay? So the difference between those is because of sampling error, because there's always going to be an error from your sample, because it's not the entire population. So what we want to do is we want to use this sample statistic to estimate the parameter. So are they significantly different from each other? Well, the way to answer this is with a hypothesis test. Okay, you can't just say, oh, well, they're only one apart, so they're pretty close. You have to actually do a hypothesis test, and that'll tell you if they're very significant from each other, or if the differences is due to chance alone. Okay, so that's the premise of doing a hypothesis test. Okay, so you can use it to answer a lot of questions, right? Such as BMI in this case. All right, so a hypothesis test is a process that uses sample statistics to test a claim about a population parameter. So the purpose of it is to take a sample statistic, use it to measure a parameter, all right, to test a claim about a parameter. So the claim, for example, was that the average BMI of the US was 26.6. How can we test this? Well, we need to take samples and then perform a hypothesis test. So let's talk about a statistical hypothesis. Statistical hypothesis is a statement about a population parameter. That's it. All it does is it talks about a population parameter. All right, so there are two types of statistical hypotheses. There's the null and the alternative. So the null hypothesis we call H sub 0. That's the little 0 on the bottom. So H sub 0. A statistical hypothesis is a statement of equality. Very simple. Null hypothesis is a statement of equality. All right, so it uses symbols like greater than or equal, less than or equal to. Alternative hypothesis is a statement of inequality. So alternative hypothesis, we use H sub 1 or we use H sub A. And therefore, since it's a statement of inequality, it doesn't have any equal signs, right? So it's greater than, strictly less than, or is not equal to. The alternative hypothesis is also known as the research hypothesis. So kind of like the scientific method, you have a observation, right? You observe something and you're like, that looks very interesting. Let me make a hypothesis about it. And then I go about testing it, right? Testing the hypothesis, and I have to use the scientific method, right? Similar to the scientific method, the hypothesis testing process generally starts with a claim, and instead of an observation, it's like a claim. Usually a claim that you want to test from an article or something like that. Someone states something, maybe a politician states something, and then you want to see, okay, let's put that to the test. Is that true? Then you have to generate a hypothesis, and then you got to test it. So how do we write a hypothesis statement? So first off, you need to know what the types of parameters are that are involved. Remember, statistical hypothesis is a statement of equality. And it's a null hypothesis, rather. A statistical hypothesis is a statement about a parameter, right? So we need to know what types of parameters to use. So here are some types of parameters that we can use. The average. You guys may remember that the population average, we use mu for the population average. Okay, let me make sure this is okay. There you go. We use mu for the population average. For the proportion, we use p for that. This is for the population proportion. The population standard deviation, we use, you guys may remember what we use for this. We use lowercase sigma for that. And then for the variance, we use sigma squared, lowercase sigma squared. So those are the symbols for the parameters that we use for population, right? Okay, so how do we go about writing the hypothesis statements? So first off, you gotta, we're gonna, describe this chart here. So you gotta know what greater than or equal to is, you gotta know what that's for. So use this chart to help you with some of the symbols. So first off, if we're talking about mean, that means we're using mu, right? So if we're talking about the mean is greater than or equal to j, then that means or at least j or not less than j. That will be considered a greater than or equal to symbol. Okay. All right. So greater than or equal to, at least, not less than. That means greater than the greater than or equal to symbol. Okay. Um, Now for HA, we're not going to do HA because that depends. We haven't talked about how to find HA yet. But here it says on the right column, it says HA, the mean is less than J, below J, or fewer than J. So if it says that, then we can use the less than symbol. And we'll talk about how to actually find these. But first you need to know, what's less than, what's below. What does that mean, basically? Less than or equal to J, very simple, just a less than or equal to symbol. You can also say at most J or not more than J. This is just different ways to convert from the math to the English. And then for HA, the mean, it says the HA, the mean is above J, so that's greater than. For equal to, very simple, it's just the equal to symbol for HO, equal to J. And then for HA, it says not equal to, so we'll say is not equal to J. Now, even though they look like they're opposites in this case, that's not always going to be the case, okay? So let me just make this clear. The HA is not always opposite of the HO, all right? A lot of times it is, but not all the time, okay? We were just doing this, they're opposites here because I wanted to give you different symbols for each thing, okay? But they're not always going to be opposites. All right. So tips for writing hypothesis statements. First step, write the claim as a mathematical statement. Then if the claim is a statement of equality, then it is called the null hypothesis. And then that's your null. If it's not a statement of equality, then it's alternative. Now, if the claim is the alternative, then the null is the complement. Complement kind of like means like opposite. Okay, so we'll say opposite. So it's kind of like the opposite of the claim. If the claim is the null hypothesis, then the alternative depends on what the researcher thinks. Okay, so if the researcher thinks is greater than, then that's going to be your alternative. Okay, so what does that actually mean? So let's look at an example. A few examples. So let's say first example, Principal Vigu claims that the proportion of seniors who graduated last year was 96%. You're not sure whether the proportion is greater than or less than this number. All right, so first off, let's do the solution for this one. The claim, which is what Mr. Vigu is saying, is that the proportion of seniors was 96%. So this as a decimal is 0.96, okay? So that's my claim, first off, that it's equal to. So then since it's equal to, this is a statement of equality, which means it belongs to the null hypothesis, okay? Or HO, which is why we put it here under HO. And so now what we said is if the claim is the null, then the alternative hypothesis depends on what the researcher thinks, right? Well, you are the researcher here. You're not sure whether the proportion is greater than or less than this number. So if you're not sure, that means it could be greater than or it could be less than. So we use not equal to. So if you're unsure or they don't give you any information, then you're going to use not equal to, okay? So if they don't give you any information, that means not equal to. All right, so for part B, which means that's my alternative. So for part B, a toilet manufacturer claims that the mean flush rate is less than, so less than, it's going to be the less than symbol, 1.6. So less than, that's a statement of inequality, which means that that's going to be the alternative hypothesis. So that means that the mean means mu, right? So mu is less than 1.6. That will be my alternative, okay? So mean less than 1.6. So that's my alternative. And now if the claim is the alternative, which the claim is the alternative in this example, If that's the case, then the null is going to be the opposite. The opposite of less than is greater than or equal to. So therefore, this is the complement. All right. So a researcher thinks that if expectant mothers use vitamin pills, the birth weight of the babies will increase. An article claims that the average birth weight of the population is 8.6 pounds. So we got a claim here. So since we have a claim, let's see here. Since we got a claim, we're gonna, and it says it's equal to 8.6. So that means mu is equal to 8.6. So that's my claim. My claim is mu equals 8.6. Now that claim is a statement of equality, which means that it belongs to the null hypothesis automatically. Now, the alternative, it depends on what the researcher thinks, right? If they don't give you any information, use not equal to. If they do give you information, use that information. So it says a researcher thinks right here, that if expectant mothers use vitamin pills, the birth weight of the babies will increase. Increase means greater than, right? So that means it's going to be greater than. So that's my alternative hypothesis. This is why the alternative hypothesis is also known as the research hypothesis, okay? This is why we call this the research hypothesis, because it depends on what the researcher thinks, and that's the hypothesis that the researcher can actually test, okay? So the research hypothesis, and it's what based on the researcher thinks. So a psychologist feels that playing soft music during a test will change the results of the test. The psychologist is not sure whether the grades will be higher or lower. In the past, the mean of the scores was 73. So in the past, the mean of the scores was 73, so that's a claim. So we'll say that that's our claim, 73. So our claim is that it was equal to 73, right? So that means it's equal to 73. So that's our claim. That's a statement of equality. It belongs to the null. The alternative, what does the researcher think? The psychologist is the researcher here. Not sure whether the grades would be higher or lower, so it's not equal to. All right, and that's how you assign hypothesis statements. So we're going to talk about type 1 and type 2 errors now, and what they represent. So again, let's kind of summarize the hypothesis testing process so far. So far, you have a claim that you want to test, and you have to make a hypothesis, right, based off of that claim. So the first part of the process is the claim hypothesis part of the step, okay? So that's the first thing. The part of the hypothesis testing involves collecting data to determine whether the null hypothesis is true or not. The goal of a hypothesis test is to determine whether the null hypothesis is true or not. So the goal is to either reject or fail to reject the null hypothesis. This is important. The end goal of hypothesis testing process is to reject or fail to reject the null hypothesis. We never use accept the null hypothesis. We usually use fail to reject. Okay. This is sort of like you're proven innocent. You're innocent until proven guilty, right? If you're on a trial, you automatically assume that they're innocent until you have enough evidence to prove that they're not innocent, rather that they're guilty, right? But you can't really prove that they're innocent, right? But you can say that they're not innocent if you have enough evidence, right? So it's kind of like that. Think of it that way. We fail to reject or reject. So first step, claim hypothesis. And then when we do that, we collect data based off of that claim, based off of that hypothesis. We need to collect data in the real world. Once we collect that data, we have to figure out, okay, well, is there enough evidence based off of the data that we collected? And by the way, we collect data using samples, right? Because we can't do the entire population, which is why we're doing the sample. So we collect data, we determine, do we have enough evidence? If the answer is yes, then that means that, oh, we reject the null hypothesis. If the answer is no, we don't have enough evidence, then we fail to reject the null hypothesis. So in the case of the court case, right, of the legal matters, we fail to reject that they're innocent. It doesn't mean that they're innocent. It just means that we don't have enough evidence to prove that they're guilty. Okay, kind of like that. So if we don't have enough evidence, we fail to reject the normal assumption. All right. So there is a chance that upon making a decision to reject or fail to reject, that your decision was a mistake. Why could there be a mistake? Well, the reason why is that you're taking samples, and samples have an instinct error to them, right? An innate error to them because you're not doing it for the entire population. You're just doing it for a sample. So a type 1 error occurs if the null hypothesis is rejected when you shouldn't have rejected it. So it was actually true, but you rejected it. That's a type 1 error. A type 2 error occurs if the null hypothesis is not rejected when you should have rejected it, meaning that it was actually false, but you failed to reject it. That's a type 2 error. So let's summarize this with a table. So the second column is the null hypothesis is true. The third column is null hypothesis is false. So if our decision was to not reject HO, but HO was true, that means that that's a correct assumption. Okay, so that's a correct assumption. It's true, and we failed to reject it, so that's fine. Now, if the null hypothesis, let's say the null hypothesis is true, but we reject it, that's an error, right? That's a type 1 error. We rejected it when we shouldn't have. Now, what happens if the null hypothesis is false, but we fail to reject it? Well, that's another error, right? So that's a type 2 error. So it's false, but we didn't reject it when we should have. It's false, but we rejected it. That's a correct decision. All right, so that's type 1, type 2 error, and then whether it's correct or not. So think of type 1 and type 2 errors kind of like our legal system. You start with your accusation, right, which is your claim. This person is guilty of this, allegedly, right? You claim that. Then we got to test that claim in court, right? The person is presumed innocent until proven guilty, which is the null hypothesis. So the null hypothesis is that the person is innocent, right? That's the null hypothesis. So null, person is innocent. All right. The alternative is person is guilty, right? So if we have enough evidence, then we can reject the innocent assumption, and therefore they're guilty, right? So they're innocent until proven guilty. So in this case, making a type 1 error is actually more harmful to the innocent than it is to convict the guilty. So basically, a type 1 error involves, remember, type 1 is you reject when you're not supposed to, right? So you're basically saying that an innocent person is guilty, and you're putting that innocent person behind bars. That's a type 1 error. That's pretty harmful to that person. Person didn't do anything, and they get convicted. That happens in our legal system quite a bit until they get proven by DNA testing, right? In the case of convicting the guilty, or not convicting the guilty, that's a type 2 error. So someone is guilty, you fail to convict them. That's not as harmful as convicting an innocent person, right? It's still pretty bad, but it's not as bad, all right? Because you can get evidence later on and then convict them, right? As long as you get another, another charge. So, just to kind of give you an idea of what it looks like in the real world, just an analog. All right. So sometimes one type of error is more serious to make than the other, which is what we talked about earlier. So let's look at another example. So identify the type 1 and type 2 errors in the situations that follow. So let P be the proportion of vegetables contaminated by E. coli. The USDA allows for 15% of vegetables to contain E. coli. A food inspector reports that a recent shipment of vegetables contained more than 15% contaminated by E. coli. All right, so let's look at the solution. First off, it says that the USDA allows for 15% to contain E. coli. Food inspector reports So someone reported that it contained more than 15%. So that means that's greater than 15%. That's a claim, right? So our claim is that it's greater than 15%. Greater than is a statement of inequality, so that belongs to our alternative, okay? So, and proportion, remember that if it's a percent or a decimal, that's you use p for that, okay? Which means that our null hypothesis has to be the opposite of that, which is less than or equal to. All right. So first off, we need to know what that is. All right. So a type 1 error occurs if you reject a null when you're not supposed to, right? So that means if the actual proportion of contaminated veggies is less than or equal to or 15%, but you rejected it. Okay, that's a type 1 error. A type 2 error occurs if the actual proportion of contaminated veggies is actually more than 15%, but you don't reject it. You fail to reject it when you should have. Okay, so it's actually more than, but you fail to reject it. All right, so that's type 1, type 2 error. So next one, a study claims that the proportion of adults who are illiterate is 7%. So we got a claim. So the claim here, and I'll just use C for claim, is that the proportion is P, is 7%. Convert that to a decimal. Now this claim is a statement of equality, so it's a null hypothesis. And we have our alternative hypothesis. Now we don't have enough information. They don't say what the researcher thinks, right? So therefore we're going to say that it's the opposite, or we're going to say that it's not equal to. If they don't say anything, then I would say if it doesn't say anything at all, then probably go ahead and use not equal to. Or use the opposite, okay? So for example, if they said that the null was less than 0.07, or less than or equal to 0.07, okay? Then you would do the opposite of that, okay? So you would do greater than. Okay, so if you don't know what the researcher thinks, then I would say use the complement, use the opposite. So in this case, the opposite here is 0.07. All right. So that's our null in our alternative, which we mentioned earlier. So a type 1 error will occur if the actual percentage who is illiterate is 7%, but you rejected it. You're not supposed to reject it because it's actually 7, but you did reject it, okay? Type 2 error is when you fail to reject it when you should have, right? So the actual proportion of illiterate adults is not 7%, right? But you failed to reject it. So let's say the actual proportion was 9%, right? But you didn't reject it. And remember that we said that our null was 7%. So you didn't reject it, but it's actually 9%, right? So that's a type 2 error. All right, guys, that's it for the video. So we talked about stating hypotheses, and we talked about type 1 and type 2 errors in this video. We'll continue the rest of it in part 2. Hope you learned a few things, and I'll see you in the next one.